Hey everybody, I'd like to make one last video. And that video is the kind of how to find the force or calculate the force using momentum. And so in this video, you'll learn how to calculate momentum as well as be able to calculate the force using the impulse momentum equation. I'm going to start out with some basic information to begin with, which we've acquired in other videos, which are things like the velocity of the car as it's coming toward the wall and the velocity of the car after it bounces off of the wall, and the duration of the amount of time that it's in contact with the wall. That's the only time that the wall can give a force to the car, and so that duration matters, as well as what is the mass of the car itself. The mass of the car that I'm going to be using, I put it in my pocket, so here it is. So we're talking about measuring this car here as it ran into a wall, and it has a mass of 33 grams, which is 0.033 kilograms. So let's start out by thinking about this equation that is this impulse momentum. Impulse is a force that acts over time. So it's a force F times a change in time. This change in time right here is already known. It's the duration of the collision. It's how long the force is able to act, and it has to only act where it's in contact with the wall. And what it causes, of force acting over time, it causes a change in momentum. And so to figure this whole thing out, first thing I need to do is figure out what my change in momentum is. A change in momentum, right? It means that I need to figure out what my momentum is kind of before the collision, and I need to figure out what my momentum is after the collision so that I can figure out in the end what my change in momentum is, which is nothing more than taking my final momentum and subtracting my initial momentum from it. That gives us a change in momentum. So, this being the case, momentum is easy to calculate because it is nothing more than the mass of the object times the velocity of the object itself. And if we're talking about the starting or initial momentum, then I just need to find it with the velocity initial. And I'm going to use the mass down here times the velocity final. I actually know all these things because they're over here on the left, so I can just plug them in to be able to figure what this out. This mass doesn't change, so it's 0.033 kilograms. And I'm going to multiply that times my velocity. And in this case, it's 0.45 meters per second. And if I multiply those two things together, I get what my momentum is. I'm going to set up the other pieces here just along the way so that I can do them all along the way at once. Oops, not 3, but 0.033 kilograms. And I'm going to multiply that times my final velocity, which is 0.1 meters per second. This is going to give me my momentum before the collision and my momentum afterwards. I'm going to grab my handy-dandy calculator to solve this, because why not? And what I get is 0.033 times 0.45. And 0.033 times 0.45 gives me 0.015. I'm rounding here a little bit, and this is going to be in kilogram meters per second. And then afterwards, if I multiply these instead, I end up with 0.003. And again, I'm rounding a bit, kilogram meters per second. So my momentum changes, but there is one more piece that I haven't mentioned in this puzzle, and that's the fact that my velocity to begin with was negative, and I missed it over here. Oh my goodness, this is so easy to miss. And so I really want this here to be a negative 0.45 instead. So a negative 0.45. Again, it's so easy to miss. And if it's negative here, then it's going to be negative here. And that's just because my velocity is negative, because I've changed direction. But it does matter quite a lot when you get down here in the change in momentum overall. So I'm going to plug in the things that I've figured out above. I've got my initial momentum and my final momentum. One of them is negative and one of them is positive. And so I'm going to take my final first, and I'm going to take 0.003 kilogram meters per second. And I'm going to subtract from that a negative value, minus 0.015 kilogram meters per second. Right? So I've now got a positive value minus a negative value, which really in a way is adding. So 0.003 plus 0.015. And what I walk away with is a change in momentum of 0.018 kilogram meters per second. This is my change in momentum. So now I've got some pieces here. I've got my two different momentum that I was able to use here to find out what my change in momentum was. And if I know what my change in momentum is, and I know what my duration of my collision is, I can solve for the force. So I'm almost done. So let's go ahead and do that down below, where I'm going to go ahead and say, hey, that force times the delta t is equal to a change in momentum over the delta t if I move the delta t over to the other side by dividing it so that I've got force all by itself. So I'm going to plug in the things that I know, and I've got 0.018 kilogram meters per second. And I'm going to divide that now by my amount of time. And my amount of time is 1/30th of a second. You could put it in decimal if you'd like, which is 0.03. Again, approximating here, seconds. And in this case here, my numbers are 0.018 divided by 0.03. And what I walk away with now is 0.6. And my units are in newtons. That is the force that this car feels when it crashes into the wall. Now, it's not a very large force. And the reason it's not a large force is that it's not a very large car, right? It wasn't in contact with the wall for very long. And so this is what we get. All right, I hope that helped. And I will see you next time. Adios.